Okay, I guess at this point, even if people are still joining us and I expect some more to come, I would like you to welcome you back to our kickoff meeting. We have switched platforms and this one seems to work very, very well. Thank you very much to Markus Walzel for providing this meeting room for us, which works much better than the big blue button. Very sorry that that happened. Very often those open source software solutions are still sort of better quality. But they will improve as well over the course of the years, hopefully. Because as a matter of fact, I used to be an open source researcher. I was very much interested in that group, and I really, really hope that they're doing well in the future. Anyway, that was a little excursus. I'm very, very happy to be able to welcome Anna Dreber Almenberg from this Stockholm School of Economics. She joins us being in her home office in Sweden. We are very happy to have you here with a topic which is really science at its best. So which scientific results can we trust? This is really at the core of what we are doing. And that's also why we have chosen to invite Anna. And at this point, I would also like to thank Jeanette very much for bringing her up and taking over the role of inviting her and also to Esther and Josefina, who took over all the organization of this talk. So I'm very happy to have you here. And without much further ado, I would like to, yeah, give you the floor. And I'm very much looking forward to your talk. Thanks for being here.
Thanks so much, and super excited to be here. Well, I'm looking forward to being back in Innsbruck. As I was saying during the break, I was there just a year ago. 11 months ago. I was there when the first few cases were reported in Innsbruck. So I'm happy being back at the end of this year, and hopefully everything is more or less fine by then. But let's see. So I apologize in advance for those who have heard some version of this talk. The talk keeps on changing, but some of the content remains the same. And then there are different versions of this. So some of you would be a bit bored. Maybe you can still get inspired somehow. Let's hope so at least, but bear with me, please. Okay, so I'm going to start with one of the examples that I probably should let go of soon, but it's always nice to, like in the afternoon, I guess, stretch out a bit, so we can start by doing that. So who here has not heard about this phenomena called power posing? Is there someone who has not heard of this? Or has everyone heard about this? I'm not seeing all videos, so I'm assuming that most of you who are not showing yourselves have not heard of this, so we can still spend a minute on it. So power posing is based on this one study published in Psychological Science in 2010 by Carn et al., where they argued that they had found that if you do a study with 42 participants, so 42 participants who are randomized to either hold a so-called high power pose, stand or sit like this for a minute or two, versus a low power pose, stand or sit like this for a minute or two, basically hugging yourself. Standing or sitting like this, not only sort of is a bit nice stretching yourself like this, but it also has these dramatic behavioral and hormonal effects. So you get higher testosterone levels, lower cortisol levels, so lower stress hormones, increased financial risk-taking measured from an incentivized gamble, the way most of us would study risk-taking in the lab, and also increase of feelings of power. What's not to like? Fantastic, like 1 or 2 minutes, and you really change yourself in so many ways. So this led to what's now the second most viewed TED Talk. My screenshot is a few months old, so it's has far exceeded 50 million views by now. And to the right, you see the risk-taking results. So those in the high power condition are statistically significantly more risk-taking than those in the low power condition. So what's the problem? Well, when we redo the study, and by we, I mean my co-authors, Eva Ranhill and others, we basically find nothing. So here's the risk-taking result. A sample size of 200, so about 5 times as big as the original study. We make it experimenter blind, and we also do some additional changes. And we basically find nothing. We did find an effect on the feelings of power, which many studies since then failed to find. So there seems to be nothing going on. So there's nothing specific about power posing in some ways, but sort of the overall public hype. Academia has left power posing behind, which is a good thing. You can get rid of false positive results from the literature, but the rest of the world continues loving power posing. So I think that's sort of anthropologically an interesting observation. But as I said, there's really nothing specific about power posing. There are many other such studies, basically where you have low-powered studies with many researcher degrees of freedom testing surprising hypothesis, and then you end up with a false positive result. Doesn't need to be the end of the world to get a false positive result, but we want to find them fairly quickly and then move on so we don't waste too many resources, our own and societies, etc., on digging into something that is just not there. So the more catchy title of today's talk could have been how researcher degrees of freedom and low statistical power have led to replication crisis, and how we should design studies and do pre-analysis plans and multiverse analysis and change incentives and do many other things if we actually take this problem seriously, which I think we should. So I'm not going to talk much about how we change incentives, but we should be thinking about this if what we're after is actually kind of finding true results while exploring sort of new things that we didn't figure out ahead of time, always. So I'm mainly going to talk about the experiments, but this is not just an experimental problem. If anything, it looks like problems are worse for non-experimental data. It's not just a social science problem. So trying to look at aggregate replication numbers for medicine makes you even sadder than what you see for, say, psychology or economics. So that this is sort of a bigger problem than just a problem we'll talk about with the examples that I will show you. Okay, so there are many reasons for why we can have false results in the scientific literature. Here are a few infamous examples. We can focus on the one to your left, which is the Wakefield et al. Study. That's the study that claimed that MMR vaccines, so the triple vaccine containing the measles vaccine, causes autism among kids. So while this paper turned out that it was just fabricated data, this paper continues to live its own life and affecting attitudes to vaccination, etc. So that's sort of really showing how, even though you have a clearly fabricated paper that's been retracted, the paper can continue having consequences. So that's, of course, problematic. And there are many more such examples of false results due to scientific con artists. But when I talk about false results, I generally don't think that they come from people like this. I mean, I think academia does not attract psychopaths to a larger degree than other fields, I'm hoping. And that's sort of my, I think, fairly well-informed prior. So I don't think that's the reason for why we see false results. So when we talk about false results, it's mainly in terms of false positive and false negative results. So we think something is happening while in fact nothing is happening, or we think nothing is happening while something in fact is happening. So those are the sort of problems that I think most of us live with. So we care a lot about p-values, in particular in economics. It's all about whether you have something statistically significant or not always, but most of the time that's something we care about. We don't discuss power much, which I think is a problem, and there's probably some variation between fields in how much, in how serious we are about power, but many of us could think even further about power, I think. And then something else that will of course contribute to which share of results we can trust is something like publication bias. So how severe is publication bias in your specific field? And there's a very nice paper by Franco et al. From a few years ago in Science, where they followed the fate of 221 different social science experiments. So these were all registered to be run on a platform called TESS. So it's almost like a pre-analysis plan ahead of time where the researchers say what they're testing, etc. It has to be approved by someone in order to be run at this platform. And then Franco et al. Follow these studies and see what happens to them depending on their results. So strong results, meaning statistically significant results, are very likely to be published and very rarely remain in the file drawer. But on your right, to the furthest right here, you can see that no results, you basically find the opposite. So they're not very likely to even be written up and shared with the rest of the research community. And of course, way less likely to be published. So that's really publication bias working for you here. So I want to spend a couple of minutes more on power, on why we should sort of take power more seriously. So there's a very nice paper by Ioannidis et al., where they go through 159 empirical econ literatures with more than 6,700 studies. And here they find that median power is about 18%. That's not very good. For neuroscience, fMRI experiments, it's about 21%. So econ is not doing better. When it comes to dictator game experiments, I mean, what experimental economist has not run a dictator game experiment at some point? Median power is about 25%. That's also a pretty bad number. And having this type of low power can be problematic for many reasons. Okay, we're less likely to find something that actually exists. So we think nothing is happening while something is in fact happening. That's a problem. But then we also have these problems that if you have a statistically significant result and low power, chances are high that if you have very low power, the true results are actually in the opposite direction from what you observe. And this is a very nice paper by Gelman and Carlin who dig further into this. And let me know if you want any references later. So there you have a bunch of reasons for why we would expect some false results in the scientific literature. And then coming back to p-values, what does a p-value actually mean? That depends on how you got that specific p-value. So we all know we shouldn't go on fishing expeditions where we're just correlating a bunch of variables with each other. If we're testing only null hypothesis, if we're testing all hypotheses that are, all these hypotheses are actually false, so the null hypothesis is true, by chance, some will end up statistically significant if you do enough tests. And if you then, of course, only report those to the world, that will obviously be misleading. And I'm sure nobody is doing this, not even undergrads at our universities. But I think there are more other common phenomena that we maybe have encouraged each other to do as reviewers or in seminars, etc. And these are p-hacking and forking. So when you're p-hacking, you're basically testing some hypothesis, but you haven't specified how you will test it. So if I do a first test, a t-test comparing my two groups, I don't find anything statistically significant. It's borderline. What happens if I do a Mann-Whitney or some other test instead? Now it's statistically significant. Or I do regression. What if I control for gender? Or what if I interact gender with treatment? What happens then? At some point, something will be statistically significant. And then you can get these weird distributions of p-values in the literature. But maybe the even more common phenomena is what Gelman and Loken call the garden of forking paths. So this is basically when you let the data tell you how to analyze it. You're testing a hypothesis. In the best of causal worlds, we've set up this experiment that's where we have treatment and control. We have this hypothesis that is clear to some extent from our design of the experiment. But once we start looking at the data, maybe we don't find anything in first test. So we start going into different subgroups, or you can analyze data in so many different ways, redefining a variable or etc. And at some point, something will be statistically significant. But the problem is that the p-value then becomes a meaningless number. And most of us like p-values and want them to be meaningful. So obviously that's not a good idea. Okay, so Simmons et al. Discuss p-hacking a lot further in their false positive psychology paper. So if we're in the world of experiments, there are just so many ways to get a p less than 0.05 result. You can stop collect data once you have a statistically significant result. You can analyze many measures, but only report those with p less than 0.05. Collect and analyze many conditions, but only report those with p less than 0.05. Use control variables in your regressions, exclude participants, etc. And once you're doing this, your false positive probability can be pretty high, even though you have a statistically significant result. So obviously problematic practices. And we've already talked about forking. So which results can we actually trust? That's going to depend on many things: the p-values, the power of the test, publication bias, the various researcher degrees of freedom, but also the prior. So what's the probability that the hypothesis is true in the first place? This is not something many of us incorporate explicitly when we evaluate results, but we do it a bit informally at least, and maybe we should do it even further, because a p less than 0.05 is not the same thing depending on the prior probability of the hypothesis, of course. Okay, so I'm going to talk very briefly about a bunch of experiments, and some of these are replication projects, and some of these are by now a bit old, but I'll be super brief about them. And then I'll talk about some work that we've been doing trying to predict replication outcomes. And I'll also talk about some new forecasting work where we're not using prediction market, but other types of tools. If there's time, I will also briefly mention this other project. And all of this is joint work with lots of people. So the person who is constant is Magnus Johannesson, who's a professor here in Stockholm, but many others like Jürgen, Felix, and Mike, who are, I don't know if they're all here, but I think I saw Felix and Mike earlier. They're also fairly constant. They're involved in almost all of these projects. So we've had these fantastic collaborations and that I hope will continue in many directions. So Felix was, for example, one of the absolute lead authors on this many analyst fMRI project. So really enjoying our collaborations together. Okay, so what do we do in these replications? And Esther, could you give me like 5 when I have 5 minutes left? Because now I can't see the time. Perfect, thanks. So we do these replications where we try to be in the world of direct replications, but it's not always clear when you're doing direct versus conceptual replications. So there's a blurry line. In the world of direct replications, we take an experiment that others have performed. We try to get as much of the original material as possible from the original authors. And then we redo the experiment with a new and typically larger sample to have high power in the test. And sorry, 1 second. Home office with 2 kids, so sorry. So, and then doing the same statistical test as in the original study too. In the world of conceptual replications, you would instead explicitly vary something in the original study and see to what extent are the original results generalizable to this new context or to this particular change of the setup. Okay, and it's not always clear what's a direct replication and what's a conceptual replication. So some people could say if you move from doing a study in Austria to doing it in Sweden, that's a conceptual replication because you're changing the setting. And others would say, no, there was nothing in the original paper saying that the original results would only hold for your Austrian sample. So this is a direct replication. But bear that in mind, and that could potentially explain some of the results. So when we do these types of replications, we say that a result replicates if we in the replication find an effect that is in the same direction of the original result as in the original study. And this new result is statistically significant in a 2-sided test. There are also other replication measures like relative effect size, Bayes factor, prediction intervals, small telescopes approach, etc. But I'm going to be focusing on this, what we call statistical significance criterion. For better and for worse. I mean, we take a continuous variable and make it binary. But I think that's also something that people then can try to predict. So that's one reason why we like it. Okay, so when we look at psychology, we were 270 authors. I played a completely minor role, looking at about 100 studies from 3 top psych journals published in 2008. This was a project that was led by Brian Nosek and took many years. Power was supposed to be high here in the sense that we have more than 90% power to detect 100% of the original effect size. This sounds good if you think that original effect sizes are not heavily inflated, even when they're true. But in this figure, you see the distribution of p-values, and you have the 97 positive statistically significant results, and something magical is definitely happening at p less than 0.05 here. And then among the 100 replications, nothing magical is happening at 0.05. So in sum, about a third of the statistically significant original results replicate according to this binary criterion. We did something very much inspired by this for experimental economics, but it's also a smaller project in ambition in the sense that we have 18 papers published in 2 top econ journals. So we went through the AER and the QGE, 2 of our top journals, and looked for all experimental papers testing a main effect. So no interactions, of course, testing a hypothesis. We have about the same power as in the psychology project, which might be a bit underpowered actually. And using the same replication criterion, we find that 11 out of 18 studies replicate. So we then set up another study where we look at nature and science replications. Nature and Science studies. So we took 21 studies published in Nature and Science between 2010 and 2015 and searched. We went through these journals and searched for all studies having between or within subject to science, testing a clear hypothesis, and using some type of subject pool that we could study. So we ended up with these 21 studies, and here we have substantially higher power. So we do a 2-round replication process where in the first round we have 90% power to detect 75% of the original effect size. If the study fails to replicate, we do a second round, stage 2, so that in the pooled sample of the 2 replications, we have 90% power to detect 50% of the original effect size. So we really have high power here and can then sort of be more sure that we don't have false negative results here. And we find that in stage 2, when we have the highest power, 13 out of 21 studies replicate. Thinking about relative effect sizes, for the 13 studies that replicate according to this binary statistical significance criterion, the relative effect size is about 75%. Whereas for the 8 studies that do not replicate according to this criterion, relative effect size is about 0%. So these 2 measures correlate pretty well here. Okay, so something that we added to these projects were prediction markets. So we're asking researchers, maybe some of you participated, to bet on the outcomes of these replications. So we want to see whether there is some wisdom of crowds, basically, and whether we get different results depending on if we have prediction markets or if we have surveys. So we set up prediction markets where participants can trade contracts that are worth $1 if the study replicates and $0 if the study does not replicate. So you can interpret such a contract as a probability that the market assigns the event. So the probability that the market thinks the study will replicate, not the probability that the market thinks the study is true, but that it will replicate given our replication endeavor. So we inform participants about how we will do the replications, etc., what power we have to find what effect size. So we set up these markets for a subset of the psychology studies, for the experimental econ studies, the nature and science studies, and also for a bunch of the many lab studies. So the many lab studies are big replication projects in psychology where lots of researchers together are replicating many results. So instead of having one lab replicating a result, 30 labs are replicating the results at the same time. If the noise in the background is too loud, let me know, because I can hear noise, but I will, sorry, one second.
It's still bearable.
Telling them off, sorry for sounding harsh, but okay. So we have other projects too, but at other stages. So these markets are open for 10 to 14 days, basically. Before they enter the markets, we ask participants, how likely do you think it is that this hypothesis will be replicated, and how well do you know the topic? So what do we find? Here I'm pooling the data for these 103 studies for which we have prediction market prices, survey beliefs, and the replication outcome. In black, like in the solid dots, we have studies that successfully replicate according to this binary statistical significance criterion. And in non-solid dots, we have studies that fail to replicate. In the simplest type of analysis, we say that if the price is above 50, the market thinks that the study will replicate. And same thing for the survey. And you can sort of visually maybe guess, yeah, it looks like there is more black above 50 than below for both prediction markets and surveys. And the prediction markets perform a little bit better. So in the simplest type of analysis, we find that the prediction markets have a 72% correct prediction rate, whereas the surveys have a 64% correct prediction rate. So better than randomness, but far from perfect. So there seems to be some wisdom of crowds. Other people, and we were involved in this Ultimate et al. Paper, but other people have used this data and other data to explore sort of whether machine learning models can predict replication outcomes. And they can to some extent, but they never perform better than the prediction markets so far, but one day I'm sure we'll get there, but not yet. So here are a few studies on those.
5 minutes.
Yes, perfect. Okay, so what have we learned from these projects? Even for true positives, original studies will probably overestimate effect sizes on average. So meta-analysis of true results will of course also overestimate effect sizes on average. So this is something we should consider. If we think that these prediction market results are generalizable, we can also, it also looks like there's something systematic about results that fail to replicate, and the markets are pretty good at picking this up. So then of course we can ask ourselves questions like, why are so many false results published? And are the incentives for replications appropriate? So we're doing more forecasting work where we're trying to predict, not using prediction market, but using surveys, whether studies will replicate and also what the results of new hypotheses will be. So in a bunch of projects, we're basically asking researchers to do very detailed work, trying to predict the results of each study. So they go through in detail the material. So this is mainly in psychology, where we're sending out the material in survey format, where you really see sort of what the participants in these experiments would see. You go through this carefully, and then we ask you a couple of questions. Basically, what's the probability that there will be a statistically significant result given this design? And what will be the standardized effect size with direction, of course. And then we also ask other questions like, do the materials provide an adequate test of the original hypothesis, etc. So we've done this for a bunch of projects now, and here's just one out of many examples. And I know that several people from Innsbruck participated here as forecasters. So thanks a lot for that, and hope you will participate in these other projects. So this is for one hypothesis here in this Land et al. Paper that was led by Justin Land and Eric Ullman. This one hypothesis was given to 15 different, or a number of different teams at the same time. They were asked to design a study to test this one hypothesis in any way they want, with the caveat that this would be run as an experiment online. Typically, you just take this one design, you do an experiment. In a good world, you also replicate that one experiment, and then you're pretty happy. So here, the idea was to look at, okay, you have this one hypothesis and 10 plus teams who all design different versions of experiments to test this hypothesis. So these are all like conceptual replications. And then we do another round of direct replication of these conceptual replications. So that's why you have these two panels and then the combined effect sizes below here. And in a normal world, you would see one of these results that, okay, maybe it was statistically significant and positive, or maybe it's statistically significant and negative, or maybe it's a null result. And here you can see for the same hypothesis, depending on who designed the study, you can get very different results. And most of them replicate directly, but obviously not conceptually. So we ask researchers to predict what the results would be here. And we find that researchers are pretty good at predicting the results. And there's no systematic under or overestimation in what researchers are predicting here in terms of effect sizes, for example. So there is something to sort of the crowd in figuring out what results would be. So maybe we should use this to a larger extent to different instances. So I will skip the super interesting Botvinnik, Netzer, Holzmeister et al. Paper, and I'm sure Felix can tell you a lot more about this. But I think this is a super cool paper. So I was super happy having been involved, and thanks you guys in Innsbruck for that. Some thoughts before concluding, and maybe this is sort of will bring up the discussion later. I think pre-analysis plans are the way forward for us doing experiments. If we want to take p-values seriously, I think pre-analysis plans are the way to go. For those that do not do experiments and have done problems doing pre-analysis plans, I think we should be doing multiverse analysis to a larger extent. Some people think we should obsess less with p-values. I'm less sure. I mean, personally, I think p-values can be super meaningful, and I think the replication projects to some extent will be the return of the p-value, because if there's anything in the original studies that correlate well with replication success, it's the original p-value. So there is some information in that. And many of us signed this manifesto basically saying that let's redefine statistical significance to p less than 0.005. Most other people think that that's a bad idea, but I think this is a good, I mean, it's another arbitrary, but at least meaningful threshold. And I think we're better off having a threshold than not having one. But some of you probably disagree. We need to have higher power. I think we should do team science to a way larger extent. To do team science, I mean, that's easy for us who are tenured to say that we should be working more in large groups, trying to figure out more about results, but doesn't go well with the current career incentives that we have for junior researchers. So I'm not sure what to do about that. If I have a minute or two, I will just say some more thoughts about pre-analysis plans. So I think the biggest problem with pre-analysis plans right now is that there is no one norm about how to report things related to pre-analysis plans. So there's a very nice paper by EPoS and Posner where they go through pre-analysis plans at the AEA registry and the equivalent in political science, and basically see, okay, to what extent are researchers following their pre-analysis plans, and when are they reporting deviations from it? And there's just unfortunately, it doesn't mean much, I think, when you see an AEA registry number on a paper, and that's very unfortunate because it could mean a lot. So I think a solution should be something like this, that if you write in a paper, all analyses below were described in the pre-analysis plan, unless otherwise specified in the text. We divided the tests in the pre-analysis plan into primary hypothesis tests, secondary hypothesis tests, robustness tests, and exploratory analysis. This is also how our results are presented. That's what I'm thinking. And if you can't do this, then I think we should do projects where we do multiverse analysis, for example, or Statistics Sweden or Statistics Austria can give you a subsample of the data, and then you commit to an analysis for the rest of the data, etc. Registered reports are also a great idea, I think, in terms of how to publish results. So registered reports are these papers where you basically submit the pre-analysis plan with an extended introduction, etc. And you get your experiment or whatever it is reviewed before you collect the data. Then the journal basically decides whether to publish this before you have any results. So here you get rid of publication bias because the results will be published no matter what they are. I think that's a fantastic idea. It's happening a lot in psychology and medicine, not much in economics and other fields. So we should look more at this, I think, if we want to take results seriously. Okay, so that's all. Well, we can talk more, but there is time in the discussion. Thanks so much for this.
Thank you so much, Anna. That was hugely interesting. I never heard about pre-registered reports before, so that's definitely not part of our kind of academic world, and it should become. Thank you so much. I'm pretty sure that there will be a number of questions out there. So at this point, how should I do that? I'm not so familiar with Zoom, so maybe people just speak up, unmute their mics, and maybe that works for us. We're still a big group, but that might work. Or maybe raise your hands, but I don't have you all on my screen.
Yes, I have a question.
Hi. Yes, go ahead.
Hi, Anna. Hi, Anna. Nice talk. Obviously, it's a very important topic. Yeah, my feeling is that currently things are really different from the old p-hacking times. So now when you try to publish a paper, referees ask for endless robustness checks, right? So a 50-page online appendix is short now, right? Normally you cross the 100-page threshold. Then people read these pre-registration, and as soon as a tiny little bit is different than realized in a paper, they scream and want the paper rejected. So I think it really became hard to publish results. And I don't think that there should be no space for some new unexpected results, right? So if we have to anticipate right from the start everything that comes out of the study, I think we kill science and we kill opportunities for young people to come up with new ideas and new results, right? So the world that you are envisioning here is really a world where only the top funded groups can do research, the rest can do theory. So, and I'm a bit concerned that this really stops science.
Okay, so very good comment. So then I think, I mean, that's not my vision of an ideal world in many ways. So when I think about pre-analysis plans, I mean, the whole point is to sort of show what what tests are confirmatory and what are exploratory tests. I think it's completely fine, and I often do this in papers too, have exploratory tests, but I think a big problem is that exploratory tests are presented as confirmatory. So you can have this pre-planned confirmatory exploratory test, and then you can have this exploratory test that you hadn't planned. So you find something unexpected in the data, and you write this down, and that should be hypothesis generating. And this, I think, allows people to explore unexpected things and find unexpected results. But it's just sort of clear at what stage we are. Are we in the hypothesis generating phase, or is this confirmatory research? So I, of course, do not want to kill exploratory research, hypothesis generating research, but I think we should just be careful of what are we actually presenting when we're presenting some results. So so we probably get different reviewers. So most of my reviewers would never read the pre-analysis plan. I don't think I've ever, I think I have one forthcoming GBO paper where the reviewers were actually not complaining about the pre-analysis plan. But the thing that happens to me more generally is that reviewers say, okay, you specified that analysis, I would have done it differently. So I think you should do it the way I wanted it instead. So they don't care whatsoever about my pre-analysis plan. For better and for worse. I mean, there can be many ways to test, to do a test. So
so my experience is completely different. People, especially the junior referees, they go to the pre-analysis plan and they really try to find a line or a word that somehow is a little bit different than in the paper, and they jump on it like crazy. And it's not one experience. It was like that in the last 4 papers, right? And
so I think this again, like I think pre-analysis plans would be super useful, can hopefully be useful, but we have to establish some norm on how to use them correctly. And I think right now, it doesn't, there's just like this tons of variation in how these are treated. And that doesn't make a lot of sense. I mean, you bring up some problems, I brought up others. I think most of these problems can be solved. So that would be awesome. Okay, Esther, I see you have a comment here.
All in for pre-analysis plans, but currently they are abused. They are abused by the referees, sometimes by the editors.
And sometimes by the authors.
Now I stop. Thanks for the talk. Great that you're here.
Thanks so much.
Hi, if I may add to this conversation, I think that there are two very important things here, right? So on the one hand side is this idea of what to do with the unexpected findings, and this has brought out now by Heine. And I think that this duality, sometimes we forget about that also, right? So in the sense that, Anna, during your talk, you talk a lot about what we expect getting and how we test we expect getting, but you didn't spend that much time in explaining your view or how to deal with these unexpected findings, which have been the driver of a lot of scientific revolutions and progressions that were unexpected, right? So I think that it's important to bring this duality in the picture. I'm sure that there are ways forward, and it's upon all of us to also consider this and the role that plays. So that's the one thing, and I'm very happy to have heard the thoughts on that, and I would encourage to remind on that as well as we move forward on this path. And the second thing is, I would like to hear a bit more your view on this idea of team science, because as you were saying, things get quickly very expensive, right? So in which way we can do better in this direction, and at the same time, we can preserve some sense of equity in the access to top science from different type of researchers, not only younger or senior, but also from different parts of the world where the science environment or the science support might be weaker.
So I think that's a super good question, and I don't have a good answer to that. I mean, I think team science, there should be more of it, and I'm not sure how to incentivize it. I mean, there are so many reasons why team science could be super useful. Like I mean, if there are these many labs that don't have much money, they can work together in order to get larger sample sizes, in order to have high power, etc. And then also things like exploring variation across contexts, across settings, etc. Team science would be super useful. How do we encourage people to do this more? I don't know. But that's sort of, I think that would be super good to think more about.
But it's not only how to encourage them, but also it's how to have this possibility from different teams, right? Because a lot of what you have been describing, these are endeavors by large consolidated teams, right? That have this spare money to invest in these very expensive projects. So one of the worries that is presented in this sort of, if we go forward down this path, is that it creates further divisions within the capacity of doing top science because of the budget constraints, basically, right? So this is something, if there's no good answer now, that's perfectly fine. But I think that this is something to take into account and to bring with us in this cognitive process of how to do better science. This should also come with how we bring equitative science that is inclusive.
Yeah, I mean, so some funders are thinking about how to encourage replications, for example. So I think it's the Dutch Research Council, or one of the big Dutch funders, that have decided to spend a proportion of their money each year on replication-related research. That's a good signal to send if you're taking replication seriously. Nothing like that is happening in Sweden. I don't know about Austria. But there is some low-hanging fruit if you care about replications. But that's a different issue than the one you just brought up, Esther. But I think they're related. Okay, so Frank first, and then hopefully Andreas too.
Yeah.
Frank?
Frank, it's your turn.
Yeah, moment. Hello.
Hello.
Hello. I'm asking from the margins, from a different discipline, so I'm not sure whether it's the very best question, because I think you are speaking from the mainstream of research, but my question comes from the margins. I think, in my understanding, you are doing research on research, and you are concluding what is the result of that? How should we rethink the logic of our operations and the theory of our understanding of the world? Yeah. So, and I see two paths. And my very simple question is, which path do you advise young scholars to follow? And I think in the logic of your findings, there are two paths, in my understanding. The first one is a methodological result. And this is, I think you are putting in question that statistical inference is sufficient. All scientists are, of course, applying inferences on their results. This is what we are doing all over the day. And so there is statistical inference, and I think you are saying scholarly or scientific inference is much more than only statistical inference. This is one result. And possibly my feeling tells me that your advice for young scholars is, please be aware that inference is much more than only statistical inference. But the second thing could also be your advice. And this is possibly the result of your research on research, is that we should suppose a slightly different model of man in our assumptions, you know. So I think the man your research is possibly supposing is no longer a bloodless man. Now it became a historical man, a human being that is a historical product. It's constituted, you know. It's not just a subject that is constituting the world, but it's a product, it's a historical product. And possibly the result of your research on research is that man is a historical product. So you put the logic of your research in a historical frame. This would be a substantial way to interpret your result. Or, so my question is, do you have in mind this substantial result or more the methodological advice?
So good. So yeah, good and interesting questions here. So I think, I mean, I agree with, I would have the first advice with the caveat. I think that to some extent, you're still, as when you're trying to maximize your career, better off being a young researcher, finding a unexpected false positive result, publishing that in a top journal, and then nobody can replicate it, but that can still lead to you getting a top job. So the career incentives are a bit messed up. But that I would advise most people to not fool themselves and fool others. And I fooled myself many times. I've worked on candidate genes. So by definition, I've done super underpowered studies and then fooled myself into thinking I have something. The second comment, I'm not sure I fully understand this, and that tells you something about me probably. But I think that most I mean, researchers are human. We react to incentives. We want to find out some truth, and we really want to find positive results. So it's not like we're always these sort of objective, emotionless beings, for better and for worse. And that would be sort of the way I see it. So I don't think that's probably exactly what you're asking, but I'm not sure I know the answer to your question. So
Frank, you're still muted. I guess this discussion is becoming so interesting that we might be willing to invest a little more time in that if you want so. Otherwise, you're very welcome to just sneak out if you have any other duties. But I'd really like to pursue that because there is another question by Andreas, and maybe at some point me myself would also have a question, but I don't have to pose it, obviously. So it's Andreas' turn.
Okay, yes, thank you, Anna, for this super interesting talk. I also think this is a very relevant topic. So my question is, in terms of kind of the conclusions and like policy conclusions, I mean, you mentioned there is kind of two things, right? There is the incentives that also the publication system creates, the career incentives connected to that. And I mean, that might be solved to some extent if journals commit to publishing some work kind of before results are known. I mean, the other thing you mentioned is that a lot of the work is underpowered. And this has nothing to do with incentives, right? This has to do with resources, usually. I mean, no one wants to do an underpowered study. It usually just happens that either you don't do your power calculations right, or you just don't have the resources and go along anyway. And I mean, you mentioned funding agencies now when it comes to funding replications, but it really seems like the funding agencies would be those institutions that should be targeted in terms of also, I mean, they need to understand if now a researcher comes and asks for twice the funding because they are, you know, we need this sample size to be much higher than they used to be in the past. So my question is there also an effort kind of that targets funding agencies and explains to them, hey, we have this problem, and for you to be part of the solution, you also need to take that into account when you give out grants?
Yeah, so okay, super interesting. I have not seen anything on that. But taking a step back on what you were saying about power, I'm not sure that, I mean, I think historically in like experimental economics, people have not taken power very seriously in the sense that nobody was doing any power calculations. That was just absent. And I think that applies to, I mean, power calculations are big in psychology now, but I think this perception that if you find something with a small sample, that's bound to be like a lower bound of the true effect. That's not true, but many people have had that idea. So in that sense, there are some incentives. If you think that that's the way things work, and if you can get those published, there are incentives to do many underpowered or low-powered studies, publish them all rather than doing a few high-powered studies, right? So in that sense, I think the incentives have been there to do low-powered studies. And then there's been some sort of ignorance, including, I mean, I've certainly been ignorant, and I feel like most papers that I was refereeing up until a few years ago in econ journals would not mention power anywhere. So you have no idea where the sample size comes from. And I think it's completely fine to say that I have this sample size because that's what I could afford. You can still do this power calculation and say, okay, I had this amount of money. Given this money, I could afford X participants. Given these X participants, here is the effect size that I have 90% power to detect. That's still an interesting exercise to do. So there's some low-hanging fruit there. But no, I haven't seen, but I mean, I don't know everything about funding agencies, but I haven't seen no funding agencies sort of really addressing this. But at the same time, who are the reviewers for most of these funding agencies? Us, right? We are reviewing, so we should be taking this more seriously. And like, if I see some proposal, it's just like, well, this is by definition underpowered. Like, there's no point in doing this exactly. Like, give them 5 times the amount or nothing if you really want to explore this question. You should be able to say this as a reviewer, I think.
Yeah,
I think that's an interesting question. And we can push funding agencies too. Like I'm using the wrong word. I'm sending a lot of emails and contacting the Swedish Research Council about these questions. So I think you guys could do the same thing with the Austrian Science Foundation and have these conversations with them. So I think p-hacking related things are related to research ethics, and I think they should consider that too. So and sort of have high power if you can, and with the caveats that it's costly, of course.
Thanks.
Definitely. Thank you very much for the question, Andreas. Marcelo wanted to ask yet a question at the end, I think.
Yes, thank you for a great talk. I was wondering a little bit what kind of advice follows from when you have a pre-registered study and you encounter unexpected results. Do you then show them as that's exploratory research, or you just don't show them and
I think you show
say for yourself, let's do another study where I do a new study with which is planned and pre-registered, and then I have confirmatory results, which in the first study have been exploratory results. That's the one thing that would follow for me as advice for how to deal with such things. The other thing is, why should I or more the discipline care about that distinction? Because in the end, it was a personal prior. How you designed your study and what you thought, what kind of results you should expect or not expect. And other people in the discipline might say, your unexpected result is a thing that I would have expected based on my expertise.
Yeah. Okay. So I'll start with a fun second question and good first question. So for the first question, I mean, if you, in an ideal world, when you have lots of money, if you do this first study, have your pre-registration, you do the analysis, and then you find something completely unexpected, it would be great to do a second study immediately and see whether you can get the same results, right? In a world where you can't, and you're just writing up the first study, and then maybe eventually you can do a second study. In the first study, I would then be like, okay, here's what we expected, here's what we found, and here's the unexpected result we found. I think, of course, that result should be shared with the world, and it should just be clear that that was exploratory. And at least for you, with your prior, that was unexpected. If someone else has another prior, they can take that into account when thinking about that result. But if we want to think about p-values in the way that they are defined, then we can do this sort of exploratory analysis and present it as confirmatory. So if you want to forget about p-values, then maybe you should drop this distinction. But if we're thinking about p-values, I think it makes so much sense to have this confirmatory tests and exploratory and make that a clear distinction. Does that make sense? But you as a reader, of course, can have the prior that I can have a prior that what you pre-registered, I would expect the opposite. Okay. And then we see what the results are. So we both learn something from this. But I think the arguments against pre-analysis plans that I think are good are that like, well, you shouldn't just be doing this one analysis. You should do the show everything, be as transparent as possible about all the types of analysis that could be done on the data. And then I let the reader decide which analysis they think is the best. And that's sort of more related to this multiverse analysis or vibration of effects, etc. If you do all the potential analysis that you can do on some data, yeah, what share of the results are statistically significant? That's interesting. So I think there are many different ways to go here, but for experiments, I think pre-analysis plans make sense.
Okay, thank you very much, Marcelo, for this question, and thank you very much, Anna, for the discussion. Maybe as a last final quick question, or maybe a remark more or less, what I see from the discussion as a primarily non-quantitative research is how much actually theory counts, and how much we should actually, even if we are empirical researchers, every once in a while step back from simply aiming to do analysis and finding results, and rather engage in conceptual thinking and saying what theory is out there, what theory are we using in our heads, and what are competing theories to use, because what we're actually talking about here is that we as researchers are facing what I call confirmation biases all the time, right? We love some theories, we love to see some results, and that's obviously what we find if we do enough analytical crunching of data in the very end, or if we sample it another sample in another environment or another cultural environment. So that to me became very clear with your talk. maybe you have an answer to that.
No, I mean, I think theory plays a role, but I'm not sure exactly what role it plays, because the theories are often so vague that it's hard to say when are you sort of, when can you reject the theory? So it's, but I think it's good to have the theories there. So I think, I mean, and some of the most interesting papers I've seen on this are from psychology. Like, I think this paper by Tagliarconi called The Generalizability Crisis is super interesting. I also think that the reply by Daniel Lakens on his blog on this is also super interesting. And they're both onto something. And it's all about sort of, generalizability of results and a little bit what's the role of theory and how do we do things. And so I'm pretty confused, as you hear, but I think that's super interesting.
Yeah, thank you very much. I hope that you will share your slides.
Yes.
I was really, really happy with this inspiring talk of yours and with the lively discussion. We could probably discuss here forever, because this is a really, really, this is primarily also something that's very important for young scholars, as we've discussed as well. So thank you so much for that. Looking forward to having you here next year, hopefully. And at this point, I'd actually like to close the session, say a very warm kind of also hello to everyone out there. Thank you so much for having joined our kickoff meeting here. And then I'm very, very hopeful that we have already seen how much of a commonality we actually have, and how much of a problem we have in common here, and how much we can learn from each other. And that's actually what we want to do here: enhance knowledge, enhance our scientific research. And that's my hope for the future. And that's a big, big invitation to keep the spirit, keep it up, and keep on doing that. We are here for you anytime. Just keep in contact with us. Also, and especially so for international people like you or Anna, keep in touch with us. Also, we are trying to keep contact from our side, from our research area, to the researchers that we have invited, so that we can reach out to the world. Basically, that's what we're trying to do with EPoS. Thanks so much for being here. Thanks so much for sharing this first kind of kickoff, and what we have in common, and what we will do in the future. I see you next time. We will announce the next meeting as soon as we know how the pandemic situation will look like. And I'm really, really hopeful that we can do that face to face. It will be somewhere in the autumn and winter. And until that time, stay tuned. Bye-bye. And thanks to everybody who helped organizing this fantastic meeting, including Esther, including Marcelo, including Eva, including Josephine. Bye-bye.